Well, welcome to this next tutorial. Today we're going to be looking at controlling some servos using millis rather than delay. One of the big issues that beginners often come across is that they start to use delay in their code and it blocks other things from working. So let's have a look at what we're trying to achieve. So what we're looking at here on this slightly shaky video is three servos moving in different directions at different speeds without blocking each other. So these are all using millis to control their movement. Now, as usual, there's a link below the YouTube video and that will take you to the Digital Town site, and there, as you can see, there is some more information. There is the circuit diagram that I'll be using and also the sketches. Now, before we get started with the code, let's just have a quick look at the circuit diagram. The circuit diagram itself is pretty simple. In fact, if you're going to use one servo, you do not need the separate 5-volt DC power supply. If you're using a single servo, you would be able to connect it to the Arduino 5 volts and the Arduino ground. However, if you're using more than one servo or you're connecting other components, an Arduino is not able to supply enough power, so you're going to need this separate power supply. In that case, your 5 volts goes to obviously the external power supply 5 volts. The ground goes to the external power supply ground, but there needs to be a link between the Arduino ground and the external supply. The rest is just a case of coming off the data pins that you are going to be using. I've chosen to use 8, 9 and 10, but you can change the code to use whichever pins you desire. Now, when people first use servos, they tend to go to the examples, go down to servos, wherever it is, there we go, and something like the sweep example. Now, this is the sweep example, and all it does is the servo moves from a position of 0 to a position of 179, and then it moves back in the opposite direction, and between each step there is a delay of 15 milliseconds. Now, a delay of 15 milliseconds on its own wouldn't cause too many problems. However, the issue comes that this is taking 179 steps. So if we go 15 milliseconds times 179, we get 2,685. That's over 2.5 seconds that it's going to take the servo to move from one position to the other, and during that sort of 2.5 seconds, it's going to be spending most of its time in a delay state. Now, if we go to the Arduino reference, here we go. Let's go down to time to delay. If we read about delay, here's the explanation of what it does. It pauses the program for the amount of time in milliseconds specified as parameter. Now, the issue that we have here, notice it pauses the program. So bringing up an example that I use all the time, this is a example of how the Arduino works. So we have our setup where we're preparing the system. The code runs through that once. Now we get into our loop. We have our inputs, our logic code, and our output. But this loop that would be reading any buttons or inputs of whatever type and driving whatever outputs you have, if you put a delay in here, this loop stops. So for the length of the delay, no inputs or outputs will be changed. Now that's very important to understand, because during the time your servo is moving, for those sort of 2.5 seconds, you can jump up and down on your buttons. You know, if you're a model railway person and you're using some kind of sensor, your sensor can be sending information as much as it wants, but the program has stopped and it will not read any data until the delay is over. So if you've got a simple movement that's blocking your program for 2.5 seconds, and if you're sweeping backwards and forwards, you could be blocking your Arduino for 5, 10, 15 seconds at a time. So these are important things to remember, and this is why we're now going to start looking at using millis to control the movement. Now, if you're not familiar with using millis to control your program, there is a link with the resource page that goes with this tutorial to state machine examples, and that will show you more about how to use millis to control the timings of things. Also, if you don't know how arrays work, there's a separate lesson on using arrays. Now, normally if I was going to use multiple servos, I'll be honest, I'd use a PCA 9685 board. That's just, for me, they're a better way to control servos, but this was a request tutorial, so we will use the servo library. So we start off creating our servo object, and we're going to call it, in this case, servo1. The reason is that obviously later I'm going to add servo2 and servo3. Now for servo1 we are going to create an array. It's a 3-element array. Notice it's an unsigned integer. That is because I did not want anybody to be able to accidentally type in a negative figure, because servos move between 0 and 179. So in the array there are 3 elements. The first element is what we're going to call the move to. That's the position that the servo is going to be sent to. We're then going to have a second element, which is going to be the current position of the servo, and finally the last element will be the speed in milliseconds, the speed between each step that the servo is going to take. Then we're going to have an unsigned long called servo1 millis, which will control the timing for this particular servo. The only other variable that gets defined is a variable I use in a lot of my sketches. I just call it current millis, and this keeps track of the current time in milliseconds since the board started. Then all I've done to sort of set this thing up, obviously we've set the servo object up already, so I'm going to start the serial monitor and then I attach the servo to pin 8. Now in the main loop I have defined a local variable called servo finished. I then start off, as I do in most of my code, where I make current millis equal to the current milliseconds since the board started. Then let's just move this code down a bit. I'm going to call a function that I've created. The return value is going to be stored in servo finished, and the function I'm going to call is servo1 control, and this is the function that is going to control obviously servo1. So this is the function servo1 control. I must admit it works, but it's not a particularly elegant solution, and part of that problem is to do with this line because it's calling the servo object. I would have preferred one function that I could have run multiple servos through, but you can't have everything, and the person who wanted this sketch wanted to use the servo library. So let's have a look at what it's going to do. The first thing we're going to do is we are going to define a value, an integer, return position. If return position is 0, that will tell the main loop that the servo has reached its final position and it's ready to receive a new destination and, if necessary, a new speed. The next thing that the function does then is immediately it sets that value to 0, and then it does a quick check on the servo.h data, the first element 0, which is the move to. So all this is doing is checking that someone hasn't put a value in that's greater than 179, because the servo will only move to 179. It won't go any further. So if someone's put a bigger number in, it's going to change it to 179 so that we don't start messing our servos up. Now the next part of the function is checking that the servo.h data move to, that's the 0, is not equal to the position that it's currently at. So if these two values were the same, then the servo has reached its final destination. Nothing else needs to happen. All we're going to do is exit the function, returning return position, and that return position will be 0. So if we get a 0 in servo finished, we know that the servo has arrived at its destination. Otherwise, if it's not equal, return position is going to equal 1. It's still moving. Now the next part we're going to do is the timing section here. So at this point we are checking to see whether it is time to take the next step. Now in our array, servo.h data element 2 stores the speed, and the speed is the milliseconds, just like you would use in the delay. This is actually saying, has enough time gone by? So has current millis minus the servo.h millis, is that greater or equal to the time for a next step? If it is, we're going to make servo.h millis equal to current millis so that it's ready and set up for the next time period. If not, it will just skip and it will wait till the next loop and until this if statement is fulfilled. But once that's fulfilled, then all it starts to do is it says, is the move to position greater than the current position? If it is, then obviously we need to move the servo.h data plus 1 position plus. If it's smaller, which is obviously the opposite in the if statement, then it's going to take 1 step in the opposite direction, and then we just write to the servo and we get our movement of 1 step. Obviously the timing, the speed, is all controlled by this value in servo.h data in the sort of the third element, element 2, because obviously arrays start at 0. So returning to the main loop, obviously all of that control has taken place in this line. All I've done here is if a value of smaller than 1 is returned, so if a 0 is returned, the servo has got to its final position, and all it's now doing is it's picking a random position between 0 and 179 for the next position that I want the servo to move to, and then it's picking a random value between 1 and 100 to put into element 2, which is going to set the speed, and then all it's doing is doing a serial print to show us what happens. So let's take a look what happens when the code is uploaded. So once again we have another shaky video, but hopefully you can see that the servo is changing direction and speed as well. Now I also added some serial print statements just to tell me the position that the servo was aiming for and the speed that it was going to do it at. And as we can see, servo.h next position, let's just stop that moving so I can do it properly. Servo.h next position 11, servo.h next speed 91. So it's going through all these random positions, just moving backwards and forwards at a variety of speeds, and it works extremely well. So if you're looking for some code that doesn't have delay in it for controlling a servo, all you need to do with this code, whatever values that you send in these two parts of the array, this is going to be the angle that you want the servo to move at. This is the speed that you're going to want it to move at. Send that, even if it was halfway through a previous movement, if you sent those values through, it would just stop going in the first direction and move straight to the new direction. However, if you want to wait until the servo has finished moving, again, wait for servo finished to be smaller than 1. Now at the beginning of the video you saw 3 servos running independently. Now for me, when I say they're running independently, that means they were each aiming for their own location at their own speed, and as you saw, even in different directions. Now if I was doing this normally, I would have used the PCA 9685 board. It would have been more elegant solution, but the person who wanted this wanted to use servo.h. So this is the way that I've done it, and it basically means you've got to create this servo object for the first servo. You've got to create an array for the servo, and you've got to give it its own unsigned long for its own timing. Now obviously I've called the object servo1, I've got servo1 data, and I've got servo1 millis. I've then had to repeat that for servo2 and servo3. Coming down a little bit further, obviously we've got the unsigned long, current millis, and then I have attached my servos onto pins 8, 9 and 10. Coming down to the main loop, we still have one variable, servo finished, and we put the value of millis into current millis at the beginning of the loop. Then we've got the same bit of code that I was using before to deal with servo1. So it calls servo1 control in this line. The rest of this code is purely to do with setting a new location when the servo gets to its final position. What I actually did for the other servos, you'll notice I got a little bit lazier. If it had finished, if it was greater than 0, it sets the direction to 0 for servo 2, and the alternate is 179. So that second servo is sweeping back from 0 to 179, and it's got a fixed speed of 30. Servo 3 is sweeping between 0 and 100, and it's doing it with a speed of 10. So each servo is, if you like, doing its own thing. They're completely separate, but the issue is that you have to rewrite, if you like, the function for each servo. So going down, obviously we've got the function that we used before, servo1 control, and what you need to do if you want to add a second servo, you're going to have to call it servo2 control, and wherever you see servo1, that's going to have to go to servo1 data now needs to go to servo2 data, and you're going to have to work your way through. Keep an eye out, because obviously there is a number of places where you're going to have to change this information. The rest of it, the return position, everything else works in exactly the same way, and that's what I did for servo 3 as well. And the results of that code, as we can see in our very shaky video, is that the 3 servos are now moving to their own individual locations without interfering or blocking each other. Now, how would I use this in a finished project? Well, as we can see, if we just look at servo 2 for now, the servo is going to move to whatever position it is given, and when it gets to its endpoint it's going to stop. So if you had a button or a sensor, all you would need to do is give it a servo to data 0, if you like, that is move to, and this one here is the speed. So you could have it that, you know, you click a button and it then says move to position whatever at speed whatever you want. If you're doing something, you know, a lot of my followers use model railway projects, so this could be part of a level crossing or whatever, and again, instead of a button it may be a sensor. When the sensor's triggered, it sends the servo to a particular position, and obviously if you've got multiple barriers you can send multiple servos to multiple positions in multiple directions all at the same time, and then when the sensor goes to 0 it would pass the opposite direction, and of course once it gets to its final position the servo is just going to sit there stationary and quiet. So that's how I would use this if I was building it into a project. So I hope that's been useful to you. Please, you know, if you've got any questions, just stick them in the comments below the YouTube video, and if there's anything specific that you would like a tutorial on, please let me know. I will probably do a follow-up to this using the PCA 9685 board, as I still think it is a better way when you are controlling multiple servos. So if you enjoyed the video, click the like and subscribe, and hopefully I'll see you in the next video. Bye for now.